Good morning, class. My name is Sakthi Rangarajan, and this is my final capstone presentation. And you can see the title right on the screen. I'm going to talk about enterprise data warehouses in this age of big data and other advancements we see around it. So this is very relevant to me because I work in this field as a data architect, and this topic is near and dear to my heart. I'll explain more about this in the later part of the presentation, but I just wanted to throw it out there first. Okay, let's get to it. All right, and here is the thesis that I worked on and the problem statement or the problem that I was trying to address. Let's talk about data. Every company generates a lot of data with their different systems and processes, and they also can get a lot of external data into their system. So the data has become a key asset for any firm who wants to improve their processes, get better at customer management, or get good product designs out there. So companies get this data, they look at this data, they analyze this data, and they get intelligence out of this data and make better business decisions. So that's the whole idea of data management, and the importance of that has been growing significantly these days. And there are other things that are also happening in the data realm. For example, all of you have heard about big data. There's an abundant amount of data out there that companies can get hold of these days, and they're figuring it out as we speak. And there are a lot of new technologies around this big data world. So this has become a disruption for the traditional data management, where EDW, the enterprise data warehouse, or I'll simply say data warehouse, has been part of this data management strategy for the past 2 or 3 decades. But right now it's in a point where it needs to make that transformation so that it can be part of this big data world, or it can get left out and become a legacy system. So big data, the EDW is in this crossroads, or in its tipping point right now, I call it. So my thesis statement is I am going to find out what are all the best practices for a data warehouse to sustain and be effective in the future in this world of big data. So that's what I'm going to analyze here. Okay, let's go on. So let me give you some background about the project work I did. Let's talk about what a data warehouse is. So an enterprise data warehouse is a large data repository where all the corporate data generated by the different transaction systems in a company, for example, order processing, customer engagement, invoice processing, everything generates a lot of data, right? All of that gets put into one big database and integrated and then made available for reporting. That's what an enterprise data warehouse is. So let's have that background and let's talk about big data a little bit. As I said, big data is let's talk about the costs of big data, what cost it. So let's go back and talk a little bit about what happened in the past 10-15 years. We have seen the rise of social media, we have seen the rise of internet connectivity for everybody, we have seen the rise of smartphones, smart devices at homes. All of these interconnected devices that are part of the internet world are generating a lot of data every single minute as we talk. Every single click we do, every single purchase we do online, everything is getting stored somewhere, and this data is huge in volume. So that's big data. The data that gets generated by this modern world is called big data. Okay, that's the other background. Let's talk about some other improvements in the technological world. Say cloud computing. You all know, I think we all use cloud. Say Office 365's cloud. Cloud is where the infrastructure, the hardware, software needed for an application or a system is maintained in a central location, and it's rented by a company or an individual. That's a huge improvement that has happened in the past few years. There are other developments like new set of technologies and databases like NoSQL databases, Hadoop based environments. Those are also, we're going to talk about them in detail next. They're also impacting the EDW. In a personal level, as I said before, I work as a data architect a lot with data warehouses. So this, I'm bringing my own experience into this paper to talk about the future of EDW. And so let's go to the approach, how I did this paper. Books, so there are some really good books written by renowned authors by the name of Bill Inman. He wrote a very influential book called Building a Data Warehouse. He actually gave the definition of a data warehouse there. And another book called Dimensional Modeling with Data Warehousing by Ralph Kimball. He's a pioneer in the data warehousing world. And another influential book by Krishnan called Data Warehouses in the Age of Big Data. That gave me a lot of reference material to write this paper. And I was able to find a lot of good articles from a lot of journals like Computer Science World and TDWI. And industry reports. I found a lot of reports from renowned companies like Gartner, Forrester, from where I was able to get a lot of information out of. The case studies are my own case studies where I worked as a data architect in the data warehousing projects in the last 2 years. We'll talk in detail about the case studies in a few. So I put all of these things together and wrote them out, massaged them, and were able to bring out the solution for this paper. So that's my methodology. What's going on? So let's dive in a little deeper into the background. So let's talk about EDW first. So if you go back 20-30 years, companies were just getting on the IT, all of their systems are getting modernized. I mean, some kind of IT system is put in place and they started generating transactional data. And people are not sure how to use that data, so they're manually pulling data out of those systems, putting them all together, trying to get some reporting out of it. And everybody's doing it, data is moving all over, it became a big mess. And that mess gave way to this concept of a data warehouse. So if you see here in the right, you can see on the left how the different systems are producing a lot of data, like operational systems, flat files. All of the data gets massaged and then moved into a central data warehouse, a big database. From there, different type of users come in and do analysis and reporting and data mining. So that's the high level concept of a data warehouse. And there are different architectures for a data warehouse. You can follow normalized architecture where you have a lot of tables and joins, or you can do a dimensional model where there is less number of tables, everything is put together in one, like a customer table, product table, and there are fact tables like sales fact where you can do analysis on the sales. I'm just putting this all in really simple terms here. And you decide the architecture and you build the data warehouse. So this is how traditionally data warehouses are being done. But what happened recently is, as I said before, the big data has come in. Big data is huge in volume. You can never predict what the data types are, and it comes in really fast. You can get data into your system every minute. But if you look at the traditional data warehouse, we load data every night, once a day or twice a day. So this huge volume of data, different variety of data, we call it unstructured data. And this huge velocity of data, it's something new for the data warehouse. It's struggling to handle this. Okay, that's happening. And cloud has come in, which has made the infrastructure, hardware, software really cheap. You can get a Amazon Cloud Services account really quickly, scale something up within a week. So data warehouse is getting pressure to move into this new world. And let's talk about Hadoop, which is open source database system built to handle big data. So a lot of people are looking at it, trying to see, hey, can we go to Hadoop for our data warehouse? That's happening. And there are new databases called in-memory databases where all the data is in the memory itself instead of being in the disk. So that's enabling analytics, advanced analytics, like predictive analytics where you can predict the future, or real-time analytics where when something is happening, you know about it right away and take actions. So those are the modern business reporting needs, right? They're not only interested in what happened before anymore, they also want to know what's going to happen, what's happening right now. On the right side, you can see a Hadoop based data warehouse as an example, where you can see this Hadoop system that feeds the data warehouse and it does all the data processing. This is one of the modern systems. I just throw it out there as an example. And let's also talk about the case studies that I did. Case study 1, it's for a storage solutions firm based in Phoenix, Arizona. They own hundreds of thousands of steel boxes and they rent it out to industries and hospitals and whatnot. So they had a data warehouse, which I like to call it a pseudo data warehouse, because it was not architected. It was just built as the needs came. There is no central schema, and the reporting were struggling. They only had 2 or 3 business analysts on site, and the rest of all the development team was offshore, and they were struggling to produce the business reports, and their data loads were really failing every day. So there was a new project to implement SAP, which is an enterprise resource planning software for the company, and they took it as an opportunity and wanted to build a new data warehouse. So I was hired as a data architect to build their data warehouse, and we built a brand new data warehouse on premise using SQL Server 2012, and we enabled ad hoc reporting. We followed Inman style architecture, and we actually delivered a dashboard for the executives, say like in 90 days after the project started. We also were able to see a lot of business engagement, which was not there before after we started this new project, which was key. We also faced some issues there, which are detailed in the paper, but I'm going to use those to derive the best practices. Alright, the next case study is with a transport authority based in Northern California. They had a manual data load and reporting solution which was not really working for them. So I went in to do EDW, brand new one for them. I interviewed their business leaders, right from the COO all the way up to the field supervisors. So the project was initiated by the operations, but I was able to bring in IT into that, and then was able to create alignment between IT and the business. The plan was to host the data warehouse in cloud, and so that made it really cheap. And we also decided to use an open source database called PostgreSQL, and that also made it really cheap and quick. So I'm going to use that information to derive the best practices. Okay, let's jump into it. Best practices. So I did all the research on cloud, big data, the new technologies, and the case studies, and came up with this list of best practices here. Number 1 for a data warehouse to be successful is business ownership. You really want your different business leaders to be engaged in different parts of the project, and you want them to feel that they own the product. Number 2, you definitely need an executive sponsor for the EDW effort. Say it could be a chief financial officer, chief operating officer, but if you can get a CXO level officer to sponsor the project, that's really ideal. The data warehouse have to embrace the new technologies, say Hadoop, or the new in-memory databases like SAP HANA. EDW should not resist it, but embrace it to be successful in the future. And it's really imperative to assemble a skilled team, because if one or two other team members are not producing or following the best practices, the work happening in the other areas would not reach the end user. And there are different reporting needs that come from the business. Some are truly business intelligence reports where you need trends and patterns. Some are operational reports, say like what's going on right now. IT needs to be aware of these things, and the systems needed for these reporting needs are different. There needs to be clear alignment between the strategy and the goals of the EDW and the business team. The team needs to have a plan and a roadmap for the data warehouse. Say, what are the capabilities we are enabling in the next 1 year, 2 year, 3 year, and how does that align with the business goals? Be careful when outsourcing the different roles within the data warehouse team. Some are not outsourceable at all. Say a data architect has to be on site. The key thing, another last one, is agile. We have to be delivering some reports or feeds or analytics every few weeks. The business does not want to wait months to get something their hands on. those are the key best practices I came up with. For conclusion, based on the study, I believe enterprise data warehouse is still relevant, will be in the future. They need to embrace the change. There's a lot of change happening. It needs to be embraced, and really need to take a hard look at cloud. It's here, everybody's using it, it's here to stay. EDW needs to get on it and follow these best practices that are outlined. They are based on personal experience and study. So most of them apply to most of the companies, so follow them and have a plan for the future. Have a roadmap, that's also important. And finally, every business has different needs and their requirements are different. Not every business needs a Hadoop system. Not every business needs a predictive analytics capability. So carefully study that and based on the business needs, come up with a solution. Okay, how is this project relevant to me? I have a lot of personal experience in data warehousing, and I've been thinking a lot about, hey, the times are changing. There's big data, there are new technologies. What I've been working on has become traditional and legacy. How I'm going to fit into this? That's one big push for me. And my career goal in the future is to start a firm doing some kind of consulting and product work in the data warehouse area. And this paper really helped me to look into that. That's the end of the presentation. Thanks a lot.